Assalamu alaikum warahmatullah. Hi everyone, this is Mr. Abdullah Faris doing the pre-response questions for the coverage of grade 12 elite for term 3, the last term for you as elite students. I hope the videos I have recorded in the previous terms were very helpful for you, and I wish you all the best in this term and in your future studies. So just keep us and remember us in your prayer. So the first question is about lesson 6.2. So this file has many questions. Some of them are multi-part, some of them are single parts. So please go through all the questions, okay? So let's begin with the first one. It says Ben rides a unicycle back and forth along a straight east-west track. The twice differentiable function B models Ben's position on the track, measured in meters from the western end of the track at time t, where it's measured in seconds from the start of the ride. The table above gives values of B of t. So B of t is the position, and V of t is the velocity measured in meters per second. Part A says use the data in the table to approximate Ben's acceleration at t equals 5. So the acceleration at t equals 5 is between t equals 0 and t equals 10. So this is what we are going to use in part A. So the answer of part A would be V of 10 minus V of 0 over 10 minus 0. If you plug in the values from the table, V of 10 is 2.3, right? Minus 2 over 10 minus 0. So that would be 0.03 meter per second squared. Be careful and pay a close attention to the units. So this is the first part. The second part says, using correct units, interpret the meaning of the integral from 0 to 60 of the absolute value of V of t dt, right? What does this integral means? And then approximate it using a left Riemann sum with the subintervals indicated by the data in the table. When this integral, it means what? It means the total distance, because there is an integral, there is an absolute value, so this is the total distance Ben rides or travels, right, from t equals 0 to t equals 60 seconds. Now we need to approximate that integral with the right Riemann sum, left Riemann sum, using the subintervals indicated in the table. So there are 3 intervals indicated in the table. So this is the first one, this is the second one, and this is the third one. So the integral from 0 to 60 of V of t dt is approximately what? Well, the width of the first rectangle will be 10 minus 0 times the height, which will be the left end point. The left end point is 2, right? The left end point is 2. plus the other one will be 40 minus 10, and the left end point is 2.3, plus the last one will be 60 minus 40, and the right end point would be, sorry, the left end point is 2.5. So this should be what? 139 meters. This is the total distance traveled from 0 to 60. Okay, so part C says for the interval, okay, must there be a time t when Ben's velocity is 2 meters per second? So this is what? This is v of t equals to, okay, for the given interval. So let's apply the mean value theorem here and check if it works or not, if it applies or not. So let's find the average rate of change between 60 and 40. So b of 60 minus b of 40 divided by 60 minus 40. Well, is this equivalent to 2? Is the average rate of change equals the instantaneous rate of change? Well, if you do that, you will get here 2, which is equal to 2. So the answer will be yes, by the mean value theorem, MVT, mean value theorem. So the mean value theorem implies that there must be a time between 40 and 60 at which the velocity is equal to 2 meters per second. Okay, so by the mean value theorem, yes, there must be a t between 40 and 60, including both 40 and 60. So let's look at the last part. The last part says a light is directly above the western end of the track. Ben writes so that at time t the distance L of t between Ben's and the light satisfies L of t all squared equals 12 squared plus b of t all squared. At what rate is the distance between Ben and the light changing at time t equals 40? So we are looking for dl over dt when t is equal to at t equals 40. This is what we are looking for, dl over dt when t is equal to 40. So to do so, you have to integrate, you have to differentiate the equation, okay? Implicit differentiation here. So this is going to be what? Let's differentiate. You get 2 L of t, right? Times, I reduced the power by 1, it's 1 now, I'm not writing it, times L prime of t, which is the thing we are looking for, equals the derivative of 12 squared is 0, so this is 2 b of t, right, times b prime of t. So we can cross out the 2's from both sides, and now we can plug in the 40, right? But we can divide by L of t, we can divide by L of t. So L prime of 40 equals b of 40 times b prime of 40 over L of 40. So from where do we get those values? Well, b of 40 b of 40 is given, it's given in the table. B of 40, if you look back at the table, b of 40 is 9. B of 40 is equal to 9 times b prime of 40. This is the same as b of 40. B prime, it's the velocity. So it's given in the table. it's 2.5, right? This is multiplied over what is L of 40. We don't know what L of 40 is, so we can find it, right? We can go back to the given formula in part D, okay? Let's do it here. From part D we have L of t squared equals 12 squared plus B of t squared, right? So we are finding L of 40, so L of 40 squared equals 12 squared plus B of 40 squared. Again, B of 40 is given in the table, right? It's given by the table as 9, so 9 squared. This is L of 40 all squared. Okay, evaluate and take the square root of both sides. L of 40 should be 15. Now put it back here. So L prime of 40 is equal to 9 times 2.5 over 15 is 1.5 meter per second. This is L prime of 40. I hope this is clear. Good luck.